Pixel density refers to how many pixels have been squeezed into a physical amount of space, often an inch. On the first Mac, there were 72 pixels per inch, which may sound like a lot, but it actually required that graphics conform to these huge pixels. Screen technology has evolved tremendously since then. Now, even the most basic computer screens are somewhere in the 115 to 160 pixel per inch range. But a new chapter in this story began in 2010, when Apple introduced an iPhone with a Retina display, a super crisp screen that doubled the pixels per inch. The result was graphics with so much more clarity than we'd ever seen. And that's because the interface elements remained the same physical size, but now it was twice as crisp. Pixel dimensions doubled. A button that was 44 pixels tall was now 88 pixels tall. Because these new devices had a ratio of 2 pixels for every 1 pixel on older devices, these displays came to be known as 1x and 2x. And designers had to start making every graphic, like icons, at 2 sizes. With these new standards came a communication problem. You could no longer say, hey, this button should be 44 pixels tall, because it should also be 88 pixels tall on a different device. There was no unit of measurement that could be used regardless of a display's pixel density. The solution was points. 1 point equates to 1 pixel on a pre-Retina display, or 2 pixels on a 2x Retina display. Points allow designers to say, hey, this button should be 44 points tall, and then any device can just multiply that number by its own pixel density ratio, like 1x or 2x, or 3x in the case of new devices like Apple's plus-sized iPhone. But of course, this isn't just for Apple devices. These days, every operating system, desktop or mobile, supports high DPI screens. By the way, DPI stands for dots per inch, which, when it comes to digital screens, is the same as pixels per inch. Google has defined their own density-independent unit for Android. They aren't called points, they're called DIPs, which stands for density-independent pixels. They're not exactly equivalent to points in iOS, but the idea behind them is the same. They're a universal unit of measurement that can be converted into pixels by using a device's scaling ratio, like 2x or 3x. Okay, get ready for the reality check. In the early days of these high-resolution mobile devices, pixel density was as simple as 1x or 2x, but now it's absolutely nuts. There are many pixel densities to support. Android is a perfect example. At the time of this video, there are 6 common pixel densities across all the different device makers. So, an icon that appears to be the same size on all of these screens actually requires 6 different graphics. For Apple devices, it's more like 2 or 3 different graphics. This is admittedly a little overwhelming, but fortunately there are some best practices for designers. To begin with, we should all be designing with vector shapes. Vector shapes contain an infinite level of detail, so you can easily export them at any size. Second, we should all be designing at 1x scale. So if we think back to that 44-point button, which turns into 88 pixels on a 2x display, we basically have 2 options when making that graphic. We could use a layout of 88 pixels and export it at the same size, 100% scale. And if we need a 1x asset, it's easy enough to export at 50% scale. But here's where we start getting into tricky territory. Scaling by less than 100% runs the risk of creating blurry results. And then new devices come along with 3x screens, and you have to export your 2x graphic at 150% scale, which again produces blurry results. The recommended approach is designing at 1x. You can then export at 200% or 300% scale for 2x and 3x assets, and the results remain pixel perfect. Okay, let's put all this pixel density stuff aside for a minute and consider this question. Should a button always be the same physical size across devices? Of course, we're just using a button as an example here, but we could be talking about an icon or text or a toolbar. Should these be a consistent size across all devices? The general consensus is that it depends. First, it depends on the precision of the input method. Touch devices require interactive elements to be larger than on computers using a cursor. In fact, the recommended minimum size for interactive elements is roughly twice as large for touch, because our fingers are fat compared to the precision of a cursor. Second, the appropriate size for an interface is dependent on the physical size of the screen itself. And third, it is dependent on your distance from the screen. Those last two kind of go hand in hand. Because a tablet has a bigger screen than a phone, we hold it farther away. Then you get to a laptop, then a desktop, then a TV. The distance increases with screen size. In fact, a button on your TV might actually be the same size as your phone, because it has to be from that distance. Here's a less dramatic and very real example of this. App icons. The app icons on a tablet need to be larger than those on your phone because you're holding it farther away. There are two ways to accomplish this. The first is using a lower pixel density. Larger screens that we use at a distance tend to have lower pixel densities. An iPad's Retina display is around 264 pixels per inch, while an iPhone's Retina display is 326. And because the iPad's screen is less dense, the pixels are larger, so the entire interface becomes slightly larger. But Apple decided that this natural increase in size still wasn't enough for app icons on the iPad. So the other way to increase their physical size is to change the actual dimensions of the icon. This requires more work for designers, but fortunately, it isn't very common outside the realm of app icons. I've also got some helpful resources for you listed below. That's an overview of pixel density when it comes to interface design. This is a huge topic, and there's a lot I've left out. Remember, design with vector shapes and design at 1x. This video is part of a larger course for Sketch Master, a collection of online training courses for the popular design tool Sketch. I've also turned this video into a free article that includes even more delightfully nerdy wisdom about this topic of pixel density.